So we'll be solving the Leetcode daily challenge problem, the length of the longest Fibonacci subsequence. Now in this given problem, you're given an array of integers, and in this array of integers, you need to find the subsequence which will eventually result to a Fibonacci series. So now in that given example, you can see that 1, 2, 3, 5, 8 actually is a Fibonacci series. Why this is a Fibonacci series? Because the sum of the two previous state will give you the sum of the current one eventually, right? And there are a lot of other possibility also. Let's take for example, there can be possibility of 1 plus 2 is 3, and or let's say that we can start with 3 comma 4, right? If we start with 3 comma 4, eventually the sum will be 7. So this is also a Fibonacci series. We should know Fibonacci series, and this is also subsequence. So it satisfies the two constraints which are given over here. The constraint is that the sum of the two previous elements should result in the sum of the current one, and the length of the Fibonacci series that shall be greater than equal to 3. So now since we have understood the given problem, now let's deep dive and start to understand what we want, how we can do this. So the first thing which comes to my mind is that brute force approach, right? The brute force approach, you can see that to make a Fibonacci series, it's not necessary we need to start with the traditional way would be that we had 1 comma 2, so we would generate another element, right? 3. But here we do not have something like this. Here we have to decide for a pair. We have to decide for a pair of AI and BI. So once we have decided this pair, based on this, we'll make a decision if the sum of these two pairs, that is CI, if CI exists in the given array, then it would make sense, right? So one thing how we can ensure that CI actually exists in the array or not. Okay, there are a lot of different ways, but one quick way is that we can use a set. Now what you can do is that you can use a set to ensure that when you do the addition, when you select two pairs like AI and BI, two, and when you take the sum and you find the sum is CI, we check that if the CI is existing in the set or not, right? So that's how we want to do. We want to calculate all the given pairs, every given possibilities, right? And at the end, we will keep on checking that if CI exists. But wait. Something bad has happened. Now we are just checking if CI exists. What if BI and CI can result to another element DI? Yep, that's exactly what that's exactly how we are going to increase the length of the Fibonacci series. So how do we find the Fibonacci series, right? There is a first element, there is a second element. If we do the addition, we find the third element. Let's call it T. Okay. Now, since we have already find out T, don't you think that we should update our variables such that to find the next fourth element, right? Find the fourth element, we will move our first element to the second element, and a third element will become a second element. Now, using this approach, we can find the fourth element. So at once I will repeat what we have done. Once we have determined that AI comma BI is a pair, we will find a CI. Now, since we have already determined that CI exists, what we can eventually do is that we can keep on expanding. We can keep on expanding to look for further elements. There can be also a DI, right? There can also be AI, and they are such elements that sum of the previous two will result into the sum of the previous two, like CI and DI, will result to EI. That's one thing we can do. So I'll just quickly show you the code, how it's going to look like. So in this given code, you can see that I have ran a two for loop. So this outer one will run from 0 to n, and this another one will run for the remaining one. Like it will run from I plus 1. So eventually what this is pretty straightforward, and it's pretty standard in the Leetcode. Like if you want to generate all the given pairs. And the next thing is that, as I already told you, that we need to find the first and the second element. Now, one thing to remember over here is that since we are interested to find the length, and since we have already assumed that we are assuming AI and BI can form a pair, we are assuming AI and BN can form a pair, hence we will assume that their length is 2. But remember, Fibonacci series will only make sense if its length is greater than equal to 3. That's why we need to take care of these cases where eventually when we are updating the max length, so what is max length? Max length is nothing. It's storing the answer for us. So at the end, let's say that you complete the complete extending of the Fibonacci series like this. What might happen is that we might need to update our length, right? We are updating a length, and at the same time, we have to update our max length as well. So max length will be so in the scenario if we do not find, like, let's say that CI does not exist, right? I will just draw X over here. CI does not exist. So you will be left updating your max length, and the max length will become 2. So we have to take care that if the max length is greater than 2, then we return max length. Otherwise, if it is less than equal to 2, then we return 0, which means that we have found no valid sequence. That's all about it. Now, one final thing which I want to tell to you here is the time complexity. Now, you might all have already guessed that since it's we are generating all the pairs, the time complexity will be of n square at least, right? But here comes the catch. We are extending it. We are extending the length. So for every given pair ai comma bi, we are finding a ci. And possibility is that we can find another di, right? We are doing this. So while extending also we are doing some operation, and hence we cannot ignore it. But what do you think? What is the max Fibonacci length which we can, what is the max Fibonacci Fn we can find? So that is given by the formula of this, right? So if you see that Fn is determined by Fn is equal to 1 by root 5 into 1 by root 5, and this is some golden ratio value. So eventually I did some research and found that you can write Fn as phi of n divided by root 5, and 5 to the power n, and 5 is the golden ratio over here. It's the golden ratio, and golden ratio is nothing this 1 plus root 5 divided by 2 into n to the power of n eventually. So this is the golden ratio, and the other part of this we are simply ignoring it because this is a very small value, and to the power of that will eventually become a more smaller value, right? So eventually what will happen is that, why I'm showing you is that the Fn, right? The Fn, the possibility of Fn to exist, because we are interested, we will keep on extending till we reach the nth value, right, of the Fibonacci of this Fibonacci series. So this will become like phi to the power n. And when we take a log on both the sides, this will become like a log of Fn into root 5 to the power log 5 into n. And we are interested in finding n. Now, let me tell you why we are interested in finding the n. Because n indicates that the n term, the total number of times, the total count of the elements. Let's say that this is an array, right, at the end of the day. So the total length of this array is determined by this nth formula. And this nth will eventually result into Fn divided by, we can ignore the constants. So this n will be something like this, approximately. You can do the math over there. So eventually we have to multiply this over here. And what will be the Fn in our case? So Fn in our case will be the max value. It will be the max value. Why? Because there is a possibility for any given pair, there is a possibility that we can reach the max value. Think about it. You generate all the given Fibonacci series, ai comma bi. There is, in the worst case, what might happen is that for every given pair, we reach the max value of the given array. And when we reach the max value, that time we say that, okay, the nth, the number of elements which are appearing in this given subsequence will be determined by the max value of the array. And that's what we are going to do over here. The array is nothing but our original, this one, not a subsequence, but this one. So eventually this will determine that, okay, in the worst case, for any given pair which we are selecting, the number of elements which might appear at max will be the max element of this given array. So you can spend some time to understand more about this, but eventually the time complexity, if I just have to write it more neatly, this will eventually be of n square into log of m, where m is the max value of the array, right? Log of m, where m is the max value of the given array, and into n square. So this becomes an interview style question, and so if you're interested for a more better solution, you can stick to the end of the video. But I think so if you are otherwise, if you are just want to watch it for fun, how we can increase the time complexity from n square into log m to n square, you can just watch the next part. So eventually, now we need to shift from a brute force approach to something more better, right? That's how, when DP will come into the picture. Now, DP is something which we need to understand is that it always relies on the previous state. We need to determine the previous state, right? We need to store the some values over here and here, and then we need to calculate the current box, right? That's how usually the DP works. right? It's not like we have to determine the future. We have, like, let's say that we did traversal this till J point, and at K point we have to see okay, using this K, can we make some changes on this state or not, right? So I'm giving you this hint because that's what we are going to do over here. And the idea is that we are going to use a 2D DP. And the 2D DP says that the given a pair of A comma B, this what is the maximum length? What is the longest Fibonacci subsequence length for this one, right? So that's what DP of I comma J indicates, right? And let's see how it will work out. So we will run for loop like we used to do, but the outer for loop will run from second element and the inner for loop will run for first element. Now hold your breath. I will tell you why we are doing this. Now think for a given scenario, right? This is the second element. This is the first element, right? Now let's say there is some previous element. We are running our DP of I comma j to determine if the second element, I should have given a better variable name, but let's say that this is a second element. Now, what I need to do is that I need to check if there exists some previous number such that I do the addition with the first number, which I have iterating over this point, will result into second element. It will result into second element. So eventually, the previous number, what will be the previous number? It will be the subtraction of the first element and the second element, right? So it will be the subtraction of the second element minus the first element. So this is how it's gonna be working out. And we have found the previous one. Now we will check if the previous can, since one thing we need to ensure in the DP is that we have to see that you know that A plus B is equal to C. But one thing is here to note is that here A is less than B, and in the C also it is less than C is actually greater than B. So this condition we need to verify. So let's say that even if we find a previous element over here, we need to ensure that it follows this given condition. Now, if it follows a given condition, that's all. That's all we need to do. We need to update our DP of I comma j. Now, DP of I comma j, as you might know, it's storing the state, it's storing the length which of the Fibonacci series, which ends at B eventually, right? So that's what we are going to do over here. And eventually, if we find previous such that the previous has satisfied this condition at least, that it is less than the B value, then we can quickly say that, yeah, the previous has some, previous can be a potential candidate and we can try to update it. Now, if the previous does not exist, we can just ignore it and make our DP of I comma j as nothing. So let me just go back and try to make how we'll store the previous value, right? So eventually what we can use is a hash map, and hash map is used to store the previous state in the sense key, let's say that at some point we have iterated at this index, right? What we can do is that we can store this previous we can store the value against the index. So the previous value will be stored against the index, and once we have reached here, we can just do the subtraction of the second and the first element and check if the previous element exists in the DP or not, right? So eventually what will happen is that we will keep on iterating, and the DP of first and second, right? Since I told you this was first, this is second. Now this would indicate that the DP of it is the length of the subsequence of Fibonacci series, right? It will be determined by this state, right? Previous and first. Because if this exists, right, I will take the potential of this one, right? Then we'll just do a +1 of this, correct? This is the main DP formula. That's all, guys. This is the main DP formula. So you need to understand if you had found a potential, I'll repeat again, if you have find a potential previous such that it satisfies all the constraint, what we can eventually do is that we can just return that DP of first, right? Because first can be used as a potential for previous state for the second element, right? First can be used as a potential state for the second element, and we just need to increment by 1. So that's all about the DP. So as I mentioned that we'll be using a 2D DP, and we are storing all the second index. Eventually we'll be, since we are iterating on the outer loop, what we can do is that since second element is at this point, right, at when we are iterating over here, we can easily store it in the hash map. So we do not need to do a separate for loop to store this hash map, correct? Now the next thing over here is that we need to do iterate over the first index, and the first index should be less than the second index. That is one thing which we have checked. And the next thing is that we have found the previous, and we check if the previous exists in the array or not. And we are checking basically using a hash map. Now in this, we have satisfied the constraint that the previous number should be less than the first index, as I had already told you, and the previous index value should be greater than 0. Because let's say in the scenario, if we have not found a previous index, that time we have to return a negative, like a invalid scenario. And what could happen is that, right, in the scenario, if there is no previous element, we can say that using first and second, we can take this as a pair, ignoring the previous. And what we can do is that F and S can eventually make up a new pair, right? And that's how we start a new subsequence with 2 element. Now, the logic behind the max length is same as in the longest subsequence, and the time complexity of this given solution is O of n square. So that's all, guys. I hope you like the video. Do like, share, and subscribe. Let me know if there is any confusion. I will try to do my best to ensure that your doubts are very much cleared. Thanks.